me.
Matt Holvey is the Manager of Innovation Operations at Bell, where he oversees the strategic operations and agile processes for developing experimental aircraft. His 7 years at Bell has spanned manufacturing, systems engineering, and commercial development, product development, excuse me. Prior to Bell, Matt served 10 years in the U.S. Navy. Thank you, Matt.
How you guys doing?
Hi, Matt.
All right, so when Bell first announced that they were developing an air taxi, that generated a lot of excitement. When we showcased an interactive cabin experience at the Consumer Electronics Show last year, that ignited the imagination of the public. However, pursuing a radical innovation like this required more than just a technological revolution. It required internal transformation as well. Bell has done 40 years of helicopter development. We're masters of vertical flight. We invented the tilt rotor technology, a vehicle that takes off like a helicopter and flies like an airplane. However, as we look forward into the future, we're going to have to really truly embrace innovation. Fortunately, Bell is no stranger to innovation. Bell has developed jetpacks. In the past, we were the first to develop an American jet aircraft. We were the first to break the sound barrier, and we were developing multi-rotor vehicles before developing multi-rotor vehicles was a cool thing to do. So, however, just embracing innovation isn't going to be enough. As we look into the future, we are seeing that technology is actually a fusion of engineering and art form. And so we have to break the chains of some of the processes that exist today and take a leap into some unknown territory. So we reached out to a creative design group and we offered some technical guidance and characteristics. And what we got back from them were some creative renderings, some concept art on how we should proceed. And I'm going to tell you, the first time the engineers took a look at this, they were like, math doesn't work. Those rotors aren't nearly the right size. All of that glass, there's no structural stability there. And so began the ping pong game back and forth between engineering designers and creative designers. The math doesn't work, right? Oh, the aesthetics are terrible with what you're suggesting. You're just never going to get off the ground, and that's fine because no one wants to get in, right? So we go back and forth, and as we do this, we start exploring and understanding how do you synthesize the technical and the creative in a space that can revolutionize the future. So engineers, this is a gross generalization, but engineers, as the left brain, it's black or it's white, there's a math problem to do. Once you solve the math, everyone's happy. And the creative designers are like, there's a whole experience involved. There's taste, there's smell, there's feel. And putting those together was a technological challenge. Interestingly, it was virtual reality that bridged that gap. When we brought virtual reality into the mix, not only was it a common platform for engineering designers, and creative designers who both work in a visual three-dimensional space, that allowed them to provide immediate feedback. We had creative designers load up 3D models, and we had pilots and engineers sit in those models and provide feedback. The controls are too far away. Okay, within 5 minutes we can move the controls closer. The window you have does not give me the visibility I need to properly pilot a vehicle. We'll make the window bigger. We'll switch around some of the structural constraints to address some of the structural design concerns. The result was the future concept vehicle that we showcased several years ago at Helicopter Expo. This is not a real vehicle, but it represents a technological path forward that Bell's pursuing. There are rotor blades on top that can morph and change shape theoretically during your mission. There's no tail rotor on the back of that tail. And internally, we tried to address more of the experiential aspects of the passenger experience, right? So we're talking about how does it look and feel inside this cabin. The materials used for the floor structure also serve an aesthetic purpose. And we went beyond that to even augment that experience, literally with augmented reality. So there's a digital overlay that allowed the passenger to actually interact with the vehicle in a way that we really haven't been able to do before. We loved this concept so much that we wanted to recreate that and push that boundary even further as we began the development of our air taxi. We wanted to do an inside-out approach, and we wanted to embrace the advanced technical aspects and the high creativity of a design team, and we wanted to do that inside out. And I'm going to use a car analogy next. So when you buy a car, at least when I buy a car, it is 10% what the car does on the road, and arguably 90% your experience when you're in this car. How does it drive? How does it make you feel? How does it aesthetically respond to you and represent you, right? Well, the problem with this analogy is that this car is a permanent decision you've made. It is your place for the life that you own the car. So we're going to move forward to a theater example where you're picking a theater seat. The theater seat is momentarily your space. However, in that momentary space, it's an experience for you, and it's a personal experience, either a good one or a bad one, until you move on and become someone else's personal experience. And using this type of mentality, we begin approaching an inside-out design to an air taxi experience. So we applied that to where does the customer sit, where does the passenger sit. We're not going to talk about the technology of the rotor system. We've got that covered. We're already the masters of vertical lift. But you put the customer in the center, what do they see? What can they reach out to? What do they interact with? Where do they put their hands? Can they touch any type of digital electronics? Where do they put their purse or their bag? As we explore this space, we apply virtual reality in even greater extents. We generate more complex models, we use more complex tools, we improve how quickly we can ideate and maturate with both creative and engineering teams. And it's allowed us to move both with velocity and to gain even greater acceptance from the public. We're able to put potential pilots into the cockpit and get their experience with how does a revolutionary new pilot control system work out. What does the customer see when they're flying in this air taxi? We're able to simulate all of these controls in a way that we've never been able to do before. As we move forward with this experience, we end up with a customer simulation that we put some future pilots in today, right? And they're going through a virtual reality experience. This is more than just a movie that they go through. You can actually interact with these vehicle controls while you're going on this mission. And you can check an email, you can change the radio station, and more than just the air vehicle itself, you're actually able to do some, walk into a queue and book your trip, go up a simulated elevator to the rooftop, and we put over 7,000 individuals through this just during the Consumer Electronics Show last year. And this creates this experience for us, and we gather feedback so that when you get into the future Bell Air Taxi, you are sitting in a singular space that's yours. However momentary it is your experience, and you are able to gain the most out of it because we designed this vehicle from the inside out. Thank you.